Okay, welcome once again to our next tutorial. It is still your tutor Peter Ekaja, and today I am bringing you the continuation of partial fractions, particularly type 1, where we have a denominator with only linear factors. I gave one example in the previous tutorial. We are adding on more and more here. Let's look at this other example. It says express 3x plus 1 divided by x plus 2 into x plus 1 into x minus 3 in two partial fractions. Hence, find the integral of the same expression. Of course, something to first appreciate before we start, like I told you earlier on in the previous tutorial, look at the power of x in the numerator. It is power 1. When you open the brackets, the denominator, the highest power will be 3. That means this is a proper fraction, and therefore we move on directly by qualifying it to be under type 1. So we shall follow the same procedure, and we shall begin by let 3x plus 1 divided by x plus 2 into brackets x plus 1 into brackets we shall now have the other factor, which is supposed to be x minus 3, and then we say this is equals to, or we can say equivalent to, a divided by the first factor, which is x plus 2, plus b divided by the second factor, which is x plus 1, and then plus c divided by the third factor, which is x minus 3. There we are. Definitely, what I said in the previous case still applies. When you look at the LCM of the right-hand side, it will be the same as the LCM, I mean the denominator of the left-hand side. That means they cancel out, and therefore, we remain with 3x plus 1 equals to a into brackets. When you get the LCM divided by x plus 2, you remain with x plus 1 into brackets x minus 3 plus b. When you get the LCM divided by x plus 1, you'll get x plus 2 into brackets x minus 3. And then finally, c. When you get the LCM divided by x minus 3, you remain with x plus 2 into brackets x plus 1. And then there we substitute again values, but we obtain these values from simply equating each of the factors to 0, one at a time. So we can begin by saying substituting x equals to negative 1. How have I got negative 1? By equating x plus 1 to 0. When you do so, what do you expect on the left-hand side? Which will be 3 times negative 1, which is negative 3 plus 2, plus 1, which gives us negative 2. On the right-hand side, when you substitute for x as negative 1, the whole first term will become 0. The whole third term will become 0. So it's only the middle term, which is going to be giving us negative 4b on the right hand side. When you substitute carefully, it will be negative 4b. That means the value of b definitely becomes a half. The value of b becomes a half. So we have got the value of b as a half. So we proceed and do the same thing to look for the other ones by substituting x equals to 3, which I've obtained by equating the second factor to 0. So x becomes 3. When you put 3 on the left-hand side, you indeed get 10. And on the right-hand side, when you substitute carefully again, you will get 20c. And therefore, the value of c also becomes a half. From there, we go on and say substituting for x equals to, now we're supposed to equate x plus 2 to 0, meaning x becomes negative 2. And when you substitute negative 2 on the left-hand side, we shall have a minus 5. On the right-hand side, we shall have 5a. That means when you make A the subject, or when you get the value of A becomes minus 1. Now that we have comfortably got the values of A, B, and C, we go back and substitute where? In the very first step that we started with here. We shall substitute there. So you can conclude and say, therefore, 3x plus 1 divided by x plus 2 into brackets x plus 1 into brackets x minus 3 will be equal to A. But our A we have got it already as negative 1. So it will be negative 1 divided by x plus 2 plus, now we shall have a half. We have a half for B, but then we shall write the expression as 1 over 2 into brackets x plus 1. And then finally, for the other C, we also got the value of C as a half, so it will be 1 out of 2 into brackets x minus 3. So that is it. We have expressed this fraction into a partial fraction. When it comes to integrating it, it is still very easy. You can now say integral of 3x plus 1 divided by x plus 2 into brackets x plus 1 into brackets x minus 3. We are having the whole of this with respect to x. We'll just be as good as integrating each of these factors. I mean, integrating each of these simple fractions. So I have integral of negative 1 out of x plus 2 with respect to x plus integral of a half. Of course, now the 2 down is multiplied by x plus 1. And then plus our integral of 1 out of 2 into brackets x minus 3 with respect to x. So from here, we can make a conclusion of these integrals, but you still need knowledge from the previous tutorials for you to manage. Uh, having the very most correct answers here. So I'm going to quote the integrals of each of them. For the first one, we expect that when you integrate negative 1 over x plus 2, the answer will be negative natural log of x plus 2. Then the next one, we shall have a half, which is a constant. Then when you integrate x plus 1, I mean 1 over x plus 1, you will get ln of x plus 1. And then finally, we shall have a half natural log of x minus 3 plus our constant. So that becomes the integral of our expression, which was 3x plus 1 divided by x plus 2 into brackets x plus 1 into brackets x minus 3 with respect to x. There we are. And that is our second example, in addition to what we had in the previous case. Let me add one more example, which is simpler, but having some small technique that we need to understand. So when you look at example 2, they're telling us to find the integral of that directly. They're telling you to integrate. But you need to first appreciate the fact that this is a proper fraction. And then the denominator is a quadratic expression which is factorizable. So what you begin by doing is you first try and check out how to factorize x squared minus 4x minus 5. We clearly know from the knowledge of factorization, we can easily see that x squared minus 4x minus 5 is actually as good as x squared minus 5x plus x minus 5. And that means at the end of the day, you have x into brackets x minus 5 plus 1 into brackets x minus 5. So at the end of the day, the expression becomes x minus 5 into brackets x plus 1. and therefore it gives us linear factors. So we can proceed by saying in our solution that let x minus 2 divided by x minus 5 into brackets x plus 1 be equal to a. This time we only have two factors down out of x minus 5 plus b out of x plus 1. And when you do this, the LCM of the right hand side is the same as the denominator of the left, so they cancel out. That means we shall remain with x minus 2 is equals to a into brackets x plus 1 plus b into brackets x minus 5. So when you look at this, it means now we can comfortably begin by substituting or putting x equals to -1. If you put -1, which is obtained from equating this factor to 0, we shall have -3 on the left. And on the right, when you put -1, we shall have -6b. When you do that carefully, the value of b becomes a half. So we are good with the value of b. Then we can also put x equals to 5. When you do so, on the left-hand side, we shall have a +3. On the right-hand side, we shall have a 6a. And therefore, the value of a also becomes a half. Now we can comfortably say that in conclusion, x minus 2 divided by x minus 5 into brackets x plus 1 is equals to a, but a is a half, so I will say 1 out of 2 into brackets x minus 5 plus b, but b is also a half, 1 over 2 into brackets x plus 1. From there, we can easily realize that x minus 2 out of x minus 5 into x plus 1 is a simple fraction. 1 over 2 into x minus 5 plus 1 over 2 into that is x plus 1. So that is how we simplify work under type 1. And now when it comes to the integration bit of it, it's really not going to be hard for us. So we can now easily say that integral of x minus 2 divided by x minus 5 into brackets x plus 1 dx is actually the same as the integral of 1 out of 2 into x minus 5 dx plus integral of 1 out of 2 into x plus 1 dx. So at the end of the day, the first integral will give us a half natural log of x minus 5 from the knowledge of integration in the previous tutorials, plus a half, again, natural log of x plus 1, and then plus our constant of integration. So basically, I think unless otherwise from this tutorial and the previous one, you should have at least got a hint on how to deal with type 1 of partial fractions. And now I can give you a simple exercise to try out. And in case you get any challenges, please get in touch with me. I will again share the contacts, but I've already shared it from even the previous tutorials. Okay, so this is our simple exercise. Try it out, and in case you get a challenge, you can feel free to contact me on WhatsApp using any of these highlighted contacts. And like I said in the previous tutorials, we offer one-on-one online teaching, and we handle learners from any level, from any country, from this world, because we feel the whole world should benefit from the gift of mathematics that we have. I wish you the best and see you again in our next tutorial. That will be type 2, where we shall talk about a denominator with a quadratic factor. Don't forget to subscribe. Don't forget to share so that people out there can benefit from these good services. Bye. See you in the next tutorial.